What's going on, guys? I'm Josh Stover and this is Stovetop 19. Today we're going to take our Stage 2 Predator 212 engine and we're going to hop this thing up to the extreme. We're going to take this to the highest level you can without having to take the motor to a machine shop. Let's get this going. So this engine is off the cooler cart build that I've been working on. It is currently a Predator 212 with a Stage 2 hop-up kit from NR Racing. I'll link their website down in the description below. Also, if you want to see this build, click on the link in the corner here to check out that video. So far with this engine, the governor has been removed. We've installed an ARC billet flywheel which has built-in timing advance. It has a bored-out Honda carburetor, 22-pound valve springs, a high-flow exhaust, and a high-flow air filter with a velocity stack. The owner and biggest Patreon supporter of this channel has since decided to take this from a pretty stout little motor to the most extreme build you can do without having to take it to a machine shop. Here's what we have for parts. For this build, we're going to be using a high compression 14cc ported cylinder head, a new cylinder head stud kit, a forged Wiseco flat top piston, and a billet connecting rod, an F275 grind cam, and he just notified me that we've actually got two bigger cams on order to test out and see how they run. We have an upgraded stainless steel valve train with 32-pound valve springs, billet steel 1.3 ratio roller rockers, and a billet dual bearing side cover, as well as a full gasket set for the engine. Any and all parts used on this big engine upgrade can be found at ombwarehouse.com. Check out the link below. Tell them Stovetop 19 sent you. First things first, on any engine build you got to tear it down. We are starting with draining the oil, removing the gas tank, the exhaust, and the carburetor. Next we take off the cylinder head as well as the push rods. Here I will also remove the side cover and remove the flywheel. Since I didn't have a puller that fit the flywheel, I simply found two bolts that fit the flywheel threaded puller holes and measured the distance from center to center. Took that measurement and drilled two holes in a piece of scrap steel and made my own puller. Next I pulled out the cam and the lifters, then unbolted the lower connecting rod cap and removed the piston and connecting rod. At this point, this is going to be the final step of the teardown before we start adding new parts. We opted to remove the oil level sensor while we had the motor opened up. Here we have broken down the new connecting rod and are installing the new rod bearings. We then assemble the connecting rod, piston, wrist pin, and secure it all together with these spiral retaining rings. The best way we have found to install these clips is to stretch the clips apart slightly, then use a small flathead screwdriver to poke the first end down into the groove, then start feeding it in and using the tip of the screwdriver, slowly start working your way around the rest of the spiral. I fought this for longer than I'd like to admit. Once the piston and connecting rod assembly was complete, it was time to install the piston rings. If you follow the instructions in the book, it will lay out everything you need to do to ensure a proper installation as far as ring placement and ring end gap clearance. We measured our ring end gap clearances by placing each ring into the cylinder bore one at a time, then using the piston to square up and push the ring halfway down into the bore, and then measured the clearance with feeler gauges, and they all met the specs for a high performance application. We then installed the piston rings in the proper location and orientation onto the piston and installed the whole assembly into the engine block, making sure to torque down the rod bolts to their rated torque according to the specs from the manufacturer. Next I'm going to install our new camshaft. This is very simple. Just drop it in and be sure to line up the timing marks on the cam and the crankshaft. At this point the bottom end is done and we can put the new billet side cover on. When installing the side cover, there is the option for installing two extra dowel pins, which we are doing, and then you need to check the crankshaft end play. It should have between 10 and 15 thousandths play with the cover fully installed. If you need more or less clearance, you just need to use the provided gaskets or using shim washers to get the correct spacing. On a side note, we had to trim our paper gasket to make clearance for one of the new dowel pins we installed. Once the billet side cover is installed, you can install the final seal from the outside, making sure it is flush with the side cover surface. Now onto the most difficult part we faced in this build, which is installing these 32-pound valve springs. I have spring compressors that work well on motorcycle and cars, but none of them would work with this setup. So what I ended up doing was making my own spring compressor utilizing the rocker stud hole, a bolt, and part of the automotive spring compressor tool. And it ended up working out pretty well. We then continued assembling the rest of the new head, reusing hardware from the old cylinder head. Things like the rocker studs, the push rod guide, carb studs, and the exhaust studs. I installed the valve lash caps. I like to put grease in the caps to ensure they remain seated properly on the valve stems until the rockers are fully installed. With the head built, we installed our head stud kit, which is an upgrade from the standard head bolts, giving us more clamping force. We also chose to increase the torque from the stock 17 foot-pounds to 25 foot-pounds due to the nature of this build and the components we have installed. Now it's time to install the new roller rockers. I double-checked that our valve lash caps are still installed and fully seated. Then I installed the upgraded stainless push rods and the new roller rockers. The spec for the valve clearance is 3/1000 of an inch and was set at this time. Finally, we just need to bolt back on the carburetor, the exhaust, flywheel, clutch, gas tank, and the outer covers, mount it back onto the cart, fill it with some oil and gas, and give it a test fire. We installed the tachometer so we can monitor the RPMs with the new setup. This will help us in dialing in needed changes for the idle due to the large cam, as well as seeing what kind of rev capability this new engine has. We were floored with the immediate difference in sound this thing had. After doing a break-in and a few heat cycles, we gave it a little bit of revving so you guys can see what this thing sounds like. There we have it, guys. We are super excited about this motor. After all the research and everything we've done, using all the components that we have, we should be up over the 20 horsepower mark, which is extremely exciting. Not to mention that we've got a bigger can to install to get more RPM out of this engine. We will also be adding nitrous in the final video, so make sure you guys stick around for that. Thank you for checking out the video. If you guys liked it, hit that thumbs up button for me. Questions or comments, drop them down below. And as always, hit that subscribe button to help my channel grow. And we will see you guys in the next video.